All right, so here we have 11.2 statistical studies and sampling methods. These next sections are just basically like vocabulary. They're not hard. They're also not really math as I consider it. What we have here, we have Jacinta and Felix. They were each asked to design and study and answer the question, what portion of students at this school listen to music while studying? First question here is, what group did Jacinta select to conduct her study? What group did Felix select from? So Jacinta chose from her friends in a gym class. And let's see, the deal was, do you listen to music while studying, which you should not do. Nor should you be listening to music while you're in class, but whatever. So Jacinta just chose from her friends in gym class. Now, I've walked down to the gym a couple of times, and a lot of kids are sitting around doing nothing, listening to music. So Jacinta's question is definitely loaded from the get-go. Felix went to the library. Then the kids in the library are probably studying. And you'll notice that the kids in the library weren't listening to music, but go to the ones in gym class, and they were. So anyways, how did Jacinta choose? Jacinta chose her friends. Felix just apparently questioned everybody that he saw in the library. And who designed a better study, Jacinta or Felix? Well, Felix did, and it's obvious because the deal was while studying. And I feel you are more likely, at least you used to be, more likely to study in the library. Now, I've walked by a library a couple of times, and it's basically just a chat zone for a couple of kids. But the truth is, you are more likely to be studying in the library as opposed to the gym. And there's other things, it looks like Felix questioned everybody. There was 100 people. All right. Jacinta only questioned her friends. Now, Jacinta's study has a lot of bias. It has a lot of bias. It's not a very good one. Jacinta has, what, 3 people that listen to music and 4 that don't. So, hers is 3 out of 7 listening to music. What is that as a percent? It's going to be a little higher than Felix. Actually, it's about the same. It's 43%. Huh. I'm really surprised at that. But still, I'm going with Felix. All right, how can you choose the best type of study to answer a given statistical question? Here we have some vocabulary here. A newspaper poll randomly selected residents in a town about which mayoral candidate they prefer. This is what is called a sample. You randomly select people and you ask them questions as a sample survey. And the definition is right there. A sample survey asks every member of a sample the same set of questions and records the answers. Next one here. A doctor conducts a clinical trial of a new blood pressure medicine by prescribing it to half the patients in the study and measuring the effect it has on their blood pressure. This is an experiment. You're introducing a variable, and you have a control group and an experimental group. A third one, a grocery store wonders how many customers bring reusable grocery bags to the store. They have an employee stand at the checkout and count the number of people using reusable bags. This is simply an observation. So in an observational study, you measure or observe members of a sample in such a way that they are not affected by the study. What we have down here says, look for relationships. In which type of study might a person be unaware that he or she is a participant? That would be an observation. Somebody is watching you and you have no idea. That's an observation. All right, choose a type of study to answer the following questions. Does urban pollution have an effect on rates of asthma? This would probably be best done through an observational study. You wouldn't, have people come in and let them breathe ozone, now would you? You wouldn't let them breathe contaminants. You wouldn't purposely try to poison somebody. So what you would do is you would observe data from different areas of the country, maybe a rural area versus an urban area, and you would make a correlation from that. So this would definitely be an observational study. Nobody would have any idea they're being monitored either. But you observe residents of urban and non-urban areas, and you compare rates of asthma over a very long period of time. Pollution probably does have something to do with asthma. It's going to agitate you a little bit. How many students in a school would like the cafeteria to serve breakfast? I would suggest a survey. Just take a survey. That would be what I would think. I was right. How about that? I agree with your textbook. Ask randomly chosen students in the school and pay attention to that randomness. Ask randomly chosen people their opinion and record the results. Last one here, a group of plants is not growing well compared to the rest. What should you change to improve? Now it says, what should you change? This is the idea of you're going to manipulate a variable, which is the definition of an experimental process. So this is probably an experiment. Split the plants into groups randomly, give each group different conditions, such as more light, more water, different fertilizer, and leave one of them alone, just to see if the new treatments show improvement. This is done all the time in agriculture. All right, moving forward. We're supposed to choose a type of study. A gym asks its customers if they would prefer the gym to open earlier in the morning. Now, I would suggest a survey, and I would introduce that idea of randomness as well. So randomly, or maybe you could do something like stratifying it, but randomly survey gym members and record the results. Number two, a gym tries out a new weightlifting method to see if it will build muscle for their customers faster than their current method. Well, this is definitely an experiment. All right. What we're going to do is we're going to have two groups. We'll have a control group where nothing changes. And then we'll have the experimental group where we introduce the new routines. Now, we will randomly assign members into each group. That's the deal right there. You got to randomly assign people in each group. A gym counts the customers who come before 8 a.m. Now, if you go to a gym, there's usually somebody at the desk. You have no idea what they're doing behind that desk. But so you wouldn't know that they're actually doing a study right now. But what they're doing is they're observing, observational study. You just observe, you record the results. Easy stuff. Here's the definition of bias. Bias is a big thing. It is. It's almost impossible to eliminate bias. A study has bias if it systematically produces results that misrepresent a population. Now, this right here means is that there's something wrong in the design of the system. It is guaranteed to design to have bias. I talked about that with Jacinta. Her study was horrible. Even Felix has had bias because the kids there were more likely to be studying. Bias might also arise if a sample is more likely to include a certain category of the population than another. For example, a poll on a website is only going to select people who go to the internet. It's not going to get old people like my parents. They're in their 80s. They're not playing around on the internet. So anything that's internet only doesn't include them. All right, determining sources of bias. Here we have a psychologist. They're conducting surveys, study the happiness levels of people who live in a neighborhood. She asked the same questions to two samples chosen from the population of the neighborhood below. So apparently she went out on a sunny Saturday and asked 100 people a question if they were happy or not. And 65%, I know that's hard to read, 65% were happy on a sunny Saturday. Well, who would have thought, right? Who would have thunk? It was sunny. It was Saturday. Of course they were happy. Still 35% of the people were not. Those little emos were inside or something. I don't know. Then on Monday, she went on a subway. She surveyed 100 people on a subway, and only 35% were happy. Now, that's due to two reasons. One, they were on a train, and two, it was Monday. Very few people are happy on Monday, probably even lower if you're on a train. So the question is, does her study have bias? This thing is loaded with bias. Both studies had bias. Of course, people are happy on a Saturday afternoon when it's sunny, and of course, people are not happy on a Monday morning in a train. So there's a crap load of bias in these questions, and surely she realized that. She's a psychologist. But who knows? Piece of paper doesn't make you smart. All right, in the following situations are the difference between groups potentially due to bias. The school wants to know the average height of its students. The school randomly chooses students and measures their height. Some students are under 5 feet and some are over 6 feet, 5 inches. I don't believe there is much bias. I think there's very little bias. And because if it was truly random, bias should be greatly eliminated. You can't eliminate it completely. If it was just, if it's one person who says they randomly selected people, there's a good chance that there is some bias in their subconscious that's happening that they may not be aware of. True randomization actually has to be done with a computer and a random number generator. You have to eliminate the persona side of things. But there's not going to be a whole lot of bias if it was truly random. So that one should be good. Now, if Coach K only talked to freshmen, or if Coach K only talked to seniors, there's a big difference in height between freshmen and seniors. All right, a soft drink company calls 500 people at random and asks, is our product or rival's product the best soft drink on the market? Why is this question a potential source of bias? Now, you might look at this and you might see the random and think, oh, it's good, right? So it's easy to see random and think no bias, but it's not always true. The way they ask the question, now, the question only talks about two different drinks. There's a whole lot more than that. You got Mountain Dew, you got Dr. Pepper, you got Coke, which you live in the South and we call everything Coke. You got Pepsi, we got root beer, A&W root beer, Fanta, which is pronounced right. It's not Fanta, it's Fanta. Look it up. And there's hundreds, there's probably thousands of soft drinks. Okay. But the way this is worded, it's only comparing two soft drinks. That's the bias. Because say you're Coke, your biggest rival is Pepsi. And that's the way it is, Coke's biggest rival is Pepsi. So if you're asking somebody, hey, is Coke better than Pepsi? Or is Coke, the way they're wording it, it's forgetting about all the little guys that are involved too. So this is definitely bias. It only talks about two soft drinks. That's the bias in it. Doesn't talk about everything else. And it's a matter of opinion. I mean, I like Dr. Pepper and I like Mountain Dew and then Coke. All right, this is just a review slide with all this. Oh, no, so we're not there. This is the sampling methods. Now, random is a big thing. They say the simplest way to use randomness is a simple random sample, but that is not something that you can always do. But even then, you have to avoid bias. So we have a couple different types of ways of sampling. There's a stratified sample. So when a population is divided into groups with similar characteristics and a sample is randomly chosen from each group, that's stratified. We have cluster when a population is divided into convenient clusters and entire clusters are chosen at random. Cluster sampling is not the best way to do it. Systematic is you start with one member chosen at random and then use a rule such as every third or fourth or fifth of the population. Systematic is a great one. And here you have high risk of bias. Convenience sampling. It's choosing only subjects that are in close proximity or easy to go. Convenience is a no. Self-selected is where people volunteer. All right, so what sampling method is used in the following examples? Is the method likely to be biased? Starting with a randomly chosen ID number, every fifth student ID number was chosen. That student was asked to fill out a survey. So this is systematic. We're choosing every fifth. Low bias. Like that's literally over here in the avoiding bias section. Low bias. A retailer put feedback cards at the front of the store. They got responses from 22% of their customers. This is convenience. They put it at the front of their store and people had to self-select it. It's also self-selected because people chose to do it. And so it's a little bit of both. And let me rephrase this. It is convenient, but it's mainly self-selected. It's actually a little of both in my opinion, but high level of bias. I am not going to fill out one of those stupid little cards unless I'm really angry about something or they're offering a big prize. So yeah, there's bias. A city wants to know what percent of people in the city own a dog or a cat. The city worker goes door to door in the neighborhood around City Hall. So this one would be the one I'd call convenience. If you look back at convenience, it deals with close proximity. It says right there, close proximity or easy to get to. High level of bias. Yeah, we're moving forward. Identify a sampling method. Which sampling method is used in the following examples? Is the method likely to be biased or not? So in the first one, a population is grouped according to age and a random sample is chosen from each group. Should be stratified. Population is divided into groups with similar characteristics and a sample is chosen from each group. So stratified. Low bias. 2, a number of hospitals around the country were randomly chosen. Within each hospital, all of the nurses were chosen. So they picked a hospital and chose all the nurses. All right. It's this guy right here. It's a cluster. When a population is divided into convenient clusters, the clusters were hospitals and entire clusters are chosen. That's a cluster. I'm not a fan of the cluster. And I don't agree about the bias, but the author of your textbook says it's low bias. And it is lower than some, but it's cluster. All right, last thing is randomizing experiments. Describe a design for controlled experiment to test a new drug for treating the flu of mice, because we would spend lots of money doing that. How does randomization apply to your design? Now, there needs to be 2 groups, and I've already kind of addressed this earlier with, I think, the gym problem. But there has to be a control group where no drug is given, and there has to be an experimental group. They are given the flu drug. Now, all mice are injected with the flu. Then they are randomly selected for the control or experimental group. And then you observe. And then you observe and count who gets the flu. And you see if there is a statistical difference. Now, just because you get the flu vaccine doesn't mean you don't get the flu. Maybe you get over it quicker. There's lots of things you can observe. Uh, in a perfect world, some of them don't get the flu. And there's always side effects of vaccines too, because most vaccines are live virus. They're a weakened form of virus. All right. I think that might be it. Oh, there's one more. Let's just try it. Design experiment test whether drinking coffee improves memory. How will you choose the experimental and control groups? So obviously here, we have two groups. We have the control group. So we randomly assign people to a control group or an experimental group. People in the control group consume no caffeine. I would not want to be in there. Sorry, no coffee. And people in the experimental group consume coffee. Now, then play memory games with both groups and compare results. A lot of this depends on the simple things too, and you have to do some randomness because a lot of people have ADHD and they probably need the coffee because it'll actually make them act more normal. Then you have people like me who are just tired 24/7. I need the coffee too because I'm tired. I know caffeine helps with me. And now finally done. That was longer than I wanted it to be. But there are your notes on statistical studies and sampling methods. I hope you enjoyed.